Alright, so yesterday we talked about our first case for our laws of sine, and that was when we were given two angles in the side, so we could just solve for our third angle by subtracting from 180. Today, since we're given two sides in an angle, we're going to have to solve a little bit differently. You don't need to write all this down. It's mostly just kind of giving you a visual. Basically, we're given two sides and an angle, okay? And it becomes a little bit tricky because whenever we solve for angles, we're going to be taking inverse signs. Agreed?
Yeah.
Are we with me?
Yeah.
To solve for the angle. When we take inverse sine of something, what are our two options for that angle that we get out? Where could it be located? If it's positive, it's a positive angle. Where is sine positive?
The first and the second quadrant.
Our first and our second quadrant. So basically, we could either get an acute or an obtuse angle. So because we're going to get two options, we have to look at, could we possibly get two triangles? Okay. Now, the other thing is, what does x have to be in order for us to be able to take sine inverse of that?
Like negative pi over 2 pi? Or is it the other numbers?
So remember that your inputs for sine inverse are your outputs for sine. So what are our outputs for sine in between?
Like negative 1 and 1?
So whatever we plug in here, right, x has to be in between negative 1 and 1. If it's not, that's where we get no solution. So some of the times we will run into cases where we can't actually make a triangle with the information that they give us. Okay? The other part is, just like normal cases, we're going to run into where we just get one solution. It's going to be pretty straightforward. However, there is the possibility that because we could perfectly angle that third angle how we needed to, we can either get the obtuse angle, which is on the inside, or the acute angle, which is on the outside. So that would be where it works out to where I can use both my acute and my obtuse angle. We can actually create two triangles. Does that make sense? So that's why a lot of times in geometry, like teachers just don't even touch on it because it can get kind of tricky. And if you don't understand what you're doing with your sine inverse, then you don't understand why we can get no or two solutions. Are we with me? Yes, maybe, at least a little bit. Like I said, you don't need to have those memorized. We're going to walk through practically how we get no solution, one solution, or two solutions. So you don't need to have these memorized. I just wanted you to kind of see the picture so we could see what it would look like. So let's look at a problem. So it says for the triangle, it says in the figure, we're going to draw it. A equals 22, B equals 12, and big A equals 42. Find the remaining side and angles. So I'm going to draw my triangle. Remember that it's okay for me to label it basically any way that I want as long as I stay consistent. So my angle A is 42 degrees, which means my opposite side has to be 22, and the opposite of my angle B has to be 12. So what do we need to find? The other angles and side C. So yesterday we started by finding side C, or our missing side, right? By setting up our ratios. So, can I set up a full ratio for A? Yeah, because I have both my side and my 42. However, what's the problem with finding little c then? There's no angle, so we would still have two unknowns there. So we can't solve for little c to start off with. Could I solve for big C to start off with?
Not really.
Nope, because again, I don't have side C, so I can't have a full ratio to where I can solve for something. So what are we left with solving for first? Big B. That's the only one we have enough information to solve for. Now, we talked about yesterday, remember that I have the ability to flip all three of my ratios depending upon what we're looking for. Since we're going to be solving for an angle, we want our angles to be on top. Y'all with me? Alright. And we said we're solving for B, so I'm going to put it on top. What's going to go underneath? 12. And we said we have to use the ratio of A, so we would have sine of 42 degrees divided by 22. So then, how do I solve for B? Okay. So is B by itself then? It's still inside the sign, so do I divide by a sign? So remember that division is not the inverse of trig function, so I can't just like divide out a sign. However, I can take the inverse sign of both sides. So I would have B equals sine inverse of all of that stuff. And then again, just like yesterday, all of these are going to have fun decimals with them, so you're going to want a calculator. We're going to plug all of that into our calculator. Make sure you are in degrees, because we're plugging in things with degrees. Yes. 3 decimals. What?
365.
So we get that B is approximately what? Like 0.3?
Yeah.
That's the
Uh,
sign.
I would make sure you're...
You have to like keep your sign right.
Yeah, so you're going to plug in that stuff, find that, but then take sine inverse of that number. 21 point what?
406.
And we're in degree. We're all okay with that? Yes? No? Maybe, but we're all able to get that in our calculator. Whatever type of calculator we use. Let's give you our first. Yes. Alright. So now, how many options did I say that there could be for B? 2, right? Because we took sine inverse of something that was positive, right? Remember that sine is positive in our first and our second quadrant. So basically what we're looking at is we have an angle of 21, so like here, okay, 0.406. However, I would still get the same sine, S-I-N-E, if I was in my second quadrant for an angle that has a reference angle of that. So how would I find that angle? My second option.
Subtract
180 minus.
Subtract it from 180, right? Yes. So I'm gonna label my second option as B prime. Basically, it's the second option. Okay. So to find our second option, we're gonna take 180 and subtract what we got to begin with. We're out with me. We all see why we're doing that. Yes. So remember, sine is positive in my first and my second. So if I'm taking sine inverse of a positive number, I have 2 different angles that could possibly be. So for us here, what would be prime B? So I'm going to take 180 minus 21.406. What is it? 158 point what? Okay, so that would be my second option. And right now, we don't know if that second option is going to work or not. Because again, remember, there are some cases that have 2 options. There are some cases that there's only 1 option. So that would be the option. We just don't know if it's going to work yet or not. And we'll look at how we can tell that in just a second. So once I have angle B, what can we find next? That we need to find in order to find little c. We can find big C, right? So how do we find big C?
Subtract all the numbers by 180.
So 180 minus A minus B gives us what?
The number.
Yes.
It's technically segment plus
Yes, there are lots of decimals because we're not dealing with exact numbers this time.
I'm not having fun anymore. $116.594.
So that. Yes.
Is that what B prime?
B.
Okay.
And because that's C. So then how would I find C prime, or my second option for C?
You just substitute.
Correct. So remember that A is given. So I can't change A. If big A or whatever information is given, that has to stay the same. Anything that I found, though, could have 2 options. So I'm still going to subtract just normal A, but now I'm going to subtract B prime. So what do we get for C prime?
I think it's negative 20.
It is. So negative what?
Negative 20.594.
Okay. Can I have a negative angle and a triangle? No. So that's what tells us that we are only looking at 1 triangle this time.
So they can be
And
two
so we can
triangles.
roll out B.
There can be 2 triangles. We will have some cases where the C prime is going to be positive, and that would give us a second triangle.
Can they be three triangles?
What? There cannot be more than 2.
You didn't get C.
Here, 180 minus A minus B. Because once I have my 2 angles, right, my angles have to add to 180, so then I can just subtract them from 180. But there can't be more than 2 options because sine is only positive in 2 quadrants, right? Or also think about it, what type of angles do we have after our second quadrant? They are bigger than 180. Can I have an angle that's bigger than 180 in a triangle? No. So there's only ever going to be 2 answers. 2, 1, or none. So then what's the last thing that we need to find?
The C value. Small C value.
Small c value. So then basically that setup is going to be really similar to what we did yesterday, okay? So we're looking for little c. So I'm going to put my little c on top. Then on bottom, we're going to have sine of 116.594 degrees. What do we want to set that equal to? Why do we want to use A?
That's the one that wasn't approximated.
Correct. So notice that we technically had to use our approximated answer to find big C, okay? There's not a way around that. Like, we have to use that approximated one. However, we don't want to use more approximations than necessary. So since they gave us both big A and little a, we're going to set it up with that ratio. So we would have 22 over sine of 42 degrees. So then, just like yesterday, I'm going to multiply by my denominator and then plug it all into our calculator. And what do we get?
29.39.
39.
9.
Oh, so 29.400. And we are in inches this time. Yes. So we have 3 pieces to our 1 answer. So those would be my 3 pieces to my answer. Alright, did we have any questions about how we went through any of those. Now, these problems are a little bit longer than the kind we did yesterday. Just because you have to look for more things. However, we're still using the same equations. But like on your test, I would only probably give you one of these. So we're all okay with the setup, how we found each of our pieces, and what to do.
Would only give us one of what?
One of a problem that gave you side-side angle. Because they're a little bit longer, I wouldn't give you more than one of those. Does that make sense? Okay. Alright, so let's look at another one. So this was to show that there is no triangle for which A equals 15, B equals 25, and A equals 85 degrees. So what's going to have to happen somewhere along the way?
The angles are going to end up being negative.
We're either going to run into a negative or we're going to run into something that we can't do. So some sort of problem has to come up somewhere. Agreed? Okay, so we're going to start though just the same way we started our other one. I'm going to draw a picture first, and we'll look at our setup the same way we looked at our previous setup. So I have big A is 85 degrees, little a is 15. I don't know big B or big C. I know that little b is 25, and I don't know little c. So again, which of my angles do I have to solve for first?
B.
B. So this is the only one that we have enough information to set up an equation for. So we have sine of big B over little b, which is what? 25? And what's that going to equal? Sine of what? So I'm setting up my ratios. What ratio do I have to use?
85.
I have to use 85 because it's the only one that I know. So sine of 85 over what? 15. So then how do I solve for b? Times it by 25, and then take sine inverse. And what do we get when we plug that into our calculator? What does it say?
It's a domain error.
Okay. Why would I have a domain error?
Is it out of the range?
I don't know. So plug this in without the sine inverse.
You get 1.66.
So notice that the stuff on the inside is 1.66. That is greater than 1. And remember, we are only allowed to plug in things in between -1 and 1. So what that tells us is that there is no such triangle.
Why'd you put the big dots?
Means therefore.
Oh.
So therefore, there is no such triangle. So they asked us to show there was no triangle. So that would be show. There's no triangle.
Oh.
Is that change? So when we run into an error like that, I would first check and see what the stuff on the inside equals. Okay? If it's bigger than 1, smaller than -1, I would make sure that you didn't like flip something incorrectly. But if you didn't, and it's still bigger than 1 or smaller than -1, then there's just no solution. Questions on that? So we covered one solution. We covered no solution. What's our last option? 2 solutions. Let's look at what that looks like. So what do we want numbers.
Draw a thing.
Draw a thing. Draw a triangle, probably. Draw a diagram. So again, they give us big A as 20.5. They don't give us big B or big C, but they give us little a and little b. So again, what do we have to start by solving for? Find big B. Basically, you're going to start by solving for whatever angle that they give you the other side to. Okay? So my setup is going to be the same. I have sine of big B divided by, this time my little b is 31. It equals, I'm using sine of what? 20.5 divided by 12. So if I wanted to solve for b, what would I do?
You multiply both sides by 31 and then inverse side.
So multiply both sides by 31 and then take our sine inverse. And when we plug that into our calculator, what do we get for b?
64.783.
Okay? Now, they told us in our directions that we're going to find two triangles where that happens. If they didn't tell us that, we would still need to look at our other option. So again, remind me, how do I find b prime?
Minus 180.
No, minus
180 minus.
from 180. There we go. So 180 minus big B. So what do we get for b prime?
115.017.
Okay, so from there, once I have b, what can we find next? What do we need to find? Before that, we want to find c. So we have big C equals 180 degrees minus a minus b gives us what? Ninety-four point 717. So then how do I find c prime?
You do that same thing except you replace the thing with the B prime.
Correct. So remember, we still have to use just normal a because that was one of our givens. But what do we get for c prime?
I think
For C prime, I got 44.2.
So is that a valid angle for a triangle? Yes. So even if they didn't tell us that there was going to be two triangles, since I found another option that works, there's going to be two triangles this time. Okay? So that means how many little c's do I need to find? Two. So basically anything that they don't give you now, we need two answers for. Does that make sense?
So if both angles are technically like correct, then you have to find two sides.
Correct. Basically we're creating two triangles now as our final answer. But their setups are going to be very similar. So I have little c divided by sine of our first big C would be 94.717 degrees. And which ratio do we want to set that equal to? A, because that was our given. So we would have 12 divided by sine of 20.5. Okay? So then how would I solve for C?
just multiply both sides by sine. You got 47.
Agreed. And what do we get?
Got 34, 149.
34. Point what?
149.
Okay, and we are in meters this time. Now notice that for C prime, my setup would be almost identical. The only difference is what angle do we have in the bottom? No, C prime this time. So when I multiply, my A ratio would stay the same, which is now we're going to multiply by sine of the 44.283 instead.
23.924.
So C prime is approximately what?
23.924.
24. And again, we are in meters. So this time, we technically still have 3 parts to each of our answers, but how many answers do we have? 2, because we have 2 triangles. So there are 6 pieces altogether. So with me? Yes.
Would we have to put like therefore 2 triangles or anything?
No. Like once you've shown that, I mean, like if you wanted to set them up like by each other, like saying first triangle B C little c, second triangle B prime C prime little c prime, you could if you wanted to organize it like that, but you don't have to say it. Because like we're not stopping, like we've solved it all the way. On the last one, like we stopped mid problem because there was no solution, so you need to give some sort of indication as to like why am I stopping? So. Other questions? Concern? Alright, so the last type of thing that we're going to cover is our area problems. So, what is the area formula that y'all know for triangles?
1/2 of base times.
Correct. What happens if we don't have height?
Figure it out.
Solve it.
How do you figure it out? If it's a right triangle, it's pretty easy because it's going to be one of your sides, right? If it's not a right triangle, is your height going to be super easy to find? No. Which is why, if they don't give us our height, and they give us 2 sides, and the included angle, we have a new area formula. For this one, you do not have to have this memorized. If you need to use it on your test, I would give it to you. Okay, however, you probably need to want it written down for your homework, because you don't have to use it on your homework. Okay, and basically all it's saying is I'm taking 1/2 times multiplying my 2 sides together, and then multiplying by sine of the included angle. So let's look at an example. So this says, find the area of a triangular lot having 2 sides of lengths 90 meters and 52 meters and an included angle of 102 degrees. So again, it's usually helpful for us to draw a triangle. So what does it mean by included angle? What's that mean?
One being
It's there.
It is.
It's inside the triangle.
Well, all of my angles are inside of this triangle.
One of the angles happens to be 100 or 100.
Okay, so let's go back to our diagram.
Okay.
What is true about angle A in comparison to B and C?
It's in between.
Okay, what's true about angle C in comparison to B and A? And what's true about angle B in terms of C and A? So what does included angle mean?
Between the two sides.
Between the two sides that are given. So that tells me that this is 90 and this is 52.
We flip them?
Yes. It would not make it even. Are you all alright with that? Which is important because if it was not the included angle, then we could not use the formula that we just got. Does that make sense? Now, it doesn't matter how we label them. If you want to label them A's, B's, and C's, you can. However, we just need to know that it is 1/2 times the two given sides times sine of the included angle. And then we're going to plug all that into our handy dandy calculator. It is kind of a big number because it is area. What do we get?
2,288.865.
2,288 point what?
865.
No. And what is our unit here?
Meters squared.
Meters squared, because it's area. Questions about that? Alright. That's all we have over laws of sine.